we're going to discuss crystals. So, ito yung FCC, BCC, HCP, ano? Tapos yung calculation ng, halimbawa given yung diameter ng atom, ng metal, tapos given yung kanyang density. So, you need to find you need to estimate the molar mass, no? Yun yung pinaka-common dito na question. Let me share my PowerPoint. Chapter 3. Pinaka-display. Oops. Mali. Wala na. Okay, so this is chapter 3 of Pallister, yung crystals. Okay, so why do we need to study the crystalline solids? So, a knowledge of crystal structure for iron help us understand the transformation that occur when steels are heat treated to improve their mechanical properties. So, anong nangyayari dyan pag nag-change ng temperature yung iron, nag-iiba-iba yung kanyang crystalline structure. So probably they have observed na pag ganito yung dapat at this temperature dapat ganito yung crystal structure. So hindi mo pwedeng apurahin yung pagpapalamig niya o kaya yung pagpapainit niya. Dapat meron silang pag nagmamanufacture ng steel, yung mga stainless steel, alam nila kung ano yung proper through experience, So hindi pwedeng mabilisan yung pagpapainit, pagpapalamig, dapat merong specific rate. So that's why we study the crystalline structure. So yun, syempre, yung stainless steel isa yan sa pinakamalaking industry, And then the other one is glass ceramic. So ganun din yung glass ceramic, Ang glass naman nagiging crystal, nagiging amorphous. Syempre that's the opposite of crystal, crystalline structure, yung amorphous, yung walang form, walang pattern. So ang glass ceramic nagiging crystal, nagiging amorphous. So ganun din 'yun, same with stainless steel. Dapat we're familiar with the crystalline structure, okay? Para mas makontrol natin yung quality ng glass. So what are crystals? Pag sinabi niyong crystal, may pattern yung organized yung atoms nila. So a crystalline material is one in which the atom are situated in a repeating or periodic array over a large atomic distances. So mamaya makikita nyo, we're going to study yung crystalline metals. So generally tatlo lang naman yan, We have the FCC, yung nasa phase yung atom, at saka yung body centered, yung BCC, at saka yung hexagonal, you have 6 atoms. You have 6 sides, Hexagon yung shape ng crystal. So tatlo lang naman yan, So all metals, you need to remember this, all metals, many ceramic materials and certain polymers form crystalline structures under normal solidification condition. So basta metal yung kino-consider natin, generally crystals yan. Ibig sabihin, may pattern yung arrangement nung mga atoms, whether it is FCC o kaya BCC o kaya HCP, may pattern. Mamaya makikita niyo. Depende kasi sa metal yan, ano? At room temperature, halimbawa, ang aluminum ay palaging FCC, gano'n, ano? Mamaya makikita niyo yung mga example ng mga metals. Pero pag nagbago yung ano, pag nagbago yung temperature, halimbawa, generally mataas sa room temperature, kahit na at room temperature FCC siya, kung saan nagbabago pa rin yung kanyang crystalline structure, ano? So when you speak of unit cell, this is the atomic order in crystalline solids indicate that the small groups of atoms form a repetitive ano pattern. Parang ito yung paulit-ulit, ano, yun yung unit cell. So halimbawa, yung FCC, yung bawat phase nung unit cell merong isang atom. Ganun yun, ano? Mamaya makikita nyo. Tapos yung unit cell sa FCC, you have ano approximately 4 atoms. Mamaya makikita niyo yan, ano? Halimbawa naman BCC yung nasa body centered, you only have 2 atoms. Dalawa lang. Makikita niyo mamaya sa illustration, yung isang unit cell. And then pag naman ano hexagonal, you will have more kasi hexagon yung shape niya, ano? You will have approximately 16 atoms. Okay? So that's a unit cell. Ito yung parang nagre-repeat na pattern dun sa crystal. Okay, so ito yung sinasabi ko na paulit-ulit yung tatlong metallic crystal structures. Ano? We have the FCC, the BCC, and the HCP. So let's take a look at each of these crystal structure. So first, let's consider the FCC. So ang FCC ay face-centered cubic, you know? So as you can see, yung atom, doon siya nakalagay sa ano, doon sa face nung cube. Nandito siya, di ba? Ano doon? Yun, nandoon yung atom. Kamukha nito, nandoon yung atom, no? Sa face siya. So ito yung crystal structure ng aluminum, copper, gold, and lead sa room temperature, no? So you will notice na dito siya yung paulit-ulit, no, na structure. Ito kamukha din. Yung nearby ano niya, kamukha din ito. Ano? So kaya nga sinasabi ko sa inyo kanina, pag FCC, bawat isang unit cell, apat na atom siya. So kung imagine niyo, bilangin niyo, 'di ba? Isa to kasi tigkalahati, no? Tapos basically ang naka-display is, 'di ba ang cube, anim na faces. So yung naka-display dito, yung tatlong faces, so you have 1.5 atom siya, ano? So yung hindi naka-display, another 1.5. So yung nasa center, 1.5 plus 1.5, 3. Tapos itong mga corners, tigwa 1/8 yan, and you have 8 corners. So this corresponds to 1 atom. So all in all, pag FCC, you have 4, di ba? You have 4 atoms. So mamaya, syempre gagamitin niyo yan sa calculation ng we wanted to estimate the molar mass, ano? So usually ang given diyan is density. So imagine niyo pag given yung density, 'di ba? Ang density mass over volume. Tapos from the, 'di ba, you have 4 atoms. So you can calculate the mass. Tapos given yung halimbawa yung formula you have the equation for the volume of the unit cell. Mamaya di-discuss natin yan. Or kung nanood kayo ng video, alam niyo na may formula yung volume ng unit cell. So that's what we're going to use for the B, no? Yan, parang ganun yung gagawin natin dito. Pagka-calculate ng atomic molar mass or atomic weight, no? Okay, so the cube edge length A, ito yung A, ito cube length. Panood nyo ba yung in-upload yung sa YouTube, no? So ito yung cube length A. The cube length edge length A and the atomic radius R for FCC. So ito yung relationship. So A is equals to 2 times the radius times the square root of 2. So kung nanood naman kayo ng video, probably makita niyo yung derivation nito, ano? So ganito kasi yung drawing pag FCC, ano? So ito yung A, then another A, kasi cube, parang square lang siya, ano? So A and then another A. Tapos the total length of the diagonal is 4 times the radius. So siyempre itong circle na to 2R to, ano? Ito another R, so that's why this is 4R. So gamitin natin yung yung Pythagorean theorem. So a squared plus a squared is equals to 4r quantity squared. So ito yung equation natin from this figure. Ano? Tapos pag sinolve natin yung a, we're going to arrive with 2r times square root of 2. So dinerive ko din to sa video, di ba? Kasi from here, starting from here, let me annotate this. So starting from right here, you will have 2a squared. Tapos yung 4r, that will become 16r squared. Ano? Okay. So pag inano nyo, tinranspose nyo yung 2 sa kabila, you will have 8r squared. Tapos kunin nyo yung square root. A is equals to square root of 8 times r. Question? And then yung square root of 8, di ba ano yan? 2 times 4 times r. Square root of 4 is 2. So that's why you have 2r times the square root of 2. So ito yung formula ng A, FCC. And then to calculate the volume, di ba? Volume is simply A times A or A cube. So just kunin nyo lang yung cube ng 2r times square root of 2. You're going to have 16r cubed times the square root of 2. So you need to remember this equation habang nag-EMSE pa tayo, So expect this in your prelims, 16r cubed times square root of 2. Kasi di ba sabi ko nga sa inyo later mag-estimate tayo ng atomic mass or atomic weight or molar mass, So ang given lang ay density. Since ang density ay equal sa mass divided by volume. So yung volume na pinag-uusapan natin dito, yung volume ng cell. Ito 'yon, Ito yung formula ng volume, 16r cubed times square root of 2. Kaya importante itong equation na ito. Of course, this is just for FCC. Iba rin siyempre pag BCC. So actually yun lang naman BCC yung iano natin kasi komplikado na pag yung yung hexagonal. Tapos another important thing here is dapat alam nyo, dapat tandaan nyo na ang N, yung number of atom sa isang unit cell ng FCC ay 4. Ba? Dinilang naman natin kanina, di ba? Okay. And then another thing is the atomic packing factor, APF. So APF is defined as the volume of atoms in a unit cell. Okay? So ito lamang ito yung volume ng atom and then divided by the total unit cell volume. Siyempre, this is always less than 1 kasi if you will take a look at this unit cell, may mga space na bakante, So kaya 'yon, less than 1 siya dapat. So yung volume of atoms in a unit cell, so gagamitin, i-assume niyo lang na yung atom ay spherical. So gagamitin niyo lamang yung 4/3 pi r cube, di ba? Yan lang naman yung volume ng itong volume ng atom. Tapos yung total unit ng cell, i-divide niyo lamang 'to ng formula natin kanina, yung kinube natin yung 2 square root of 2r cube, Di ba? Ano lang naman yun? 16r cube times the square root of 2. Diba? Tama ba? Kasi di ba 2 square root of 2, tapos kinube natin. So 2 times 2, 4, 4 times 2, 8. Tapos 8 times 2, square root of 2. Tandaan nyo ba? So that's why this will become 16 square root of 2. So, may square root of 2 pa. So, magka-cancel out lamang to. Tapos yun, you can use the calculator. So, pag ginamit niyo yung calculator, di ba, you're supposed to get something like 0.74. Tama? So, 4 divided by 3 times pi. Tapos, divided by 16 times square root of 2. Kasi tama. You have 4 ano. I forgot to multiply this by, you have 4 atoms, ano? You have 4 atoms. So times 4 pa yan. So yun, times 4, di ba? 0.74. You have any question regarding APF, atomic packing factor? Basically, this means ito yung ito yung volume ng atom divided by yung total volume ng unit cell. So for FCC, this is approximately equal to 0.74, no? I hope napalabas na sa calculator. Okay. So ito rin yun, ano? Ito rin yung problem example, 3 point something, 3.2. Ito rin yun, ano? So BS divided by BC, volume of atoms divided by volume of unit cell. So yung volume ng atom 4 times, this is the formula of the sphere, no? Yung R is yung radius ng atom. So yun, times 4. You have 16 divided by 3 pi R cube. Tapos yung yung formula ng unit cell volume is 16 R cube times square root of 2. Kapag dinivide, magka-cancel lang ito, and then use your calculator, you're going to get this 0.74. Questions so far? Tapos let's take a look at the body-centered cubic crystal structure. So example naman ito is iron, yung BCC. At saka chromium, pareha sila ng structure. Pag nagagawa ng stainless steel, ito yung pinaghahalo, di ba? Para hindi kalawangin yung iron. Ito yung sacrificial anode, yung chromium. You're familiar with that concept? Sacrificial anode. Ito muna yung kakainin ng ito muna yung magre-react sa air, yung chromium, hindi yung iron. Yung principle ng stainless steel. May chromium. So as you can see, yung kaibahan niya sa FCC, yung isang atom nasa gitna, nasa center, wala sa face, So that's why this is body-centered cubic crystal structure. Okay? So pag tiningnan niyo naman to, hindi na apat na atom sa isang unit cell. Dalawa na lang, di ba? Yung isang nasa gitna, tapos tigwa 1/8 yan, yung nakapalibot na hati-hati. So 1 plus 1, 2. Kasi 8 yung di ba? 8 tigwa 1/8, so 2. So pag BCC, you only have 2. You only have 2 atoms in 1 unit cell. Okay? So example niya is sa iron at saka sa chromium. Kita niyo naman dito, imagine naman paulit-ulit lang yan. So ganun pag crystal, paulit-ulit may paulit-ulit na unit cell. Most of the metal are crystals. Okay? So ito yung formula natin ng A. Remember, ang A ay ito. Ito yung A natin. Yung isang side. As you can see, cube pa rin yan. Same yung height at saka yung width at saka yung kanyang yung thickness niya, pare-parehas lang yan. So kung kanina sa FCC, 'di ba sa FCC ay ang A ay 2 square root of 2 times R. Dito naman 4R divided by square root of 3. So paki-browse yun na lang either sa solutions manual, o kaya sa libro, nandoon yung derivation nito, yung 4R divided by square root of 3. Okay? So ang BCC nito ay 0.68. Nandoon din yan sa libro kung paano na-derive yung 0.68 sa yung APF ng BCC. Siyempre, mas mababa kasi dalawa lamang yung niya. Dalawa lang yung kanyang molecule. Dalawa lang yung kanyang atom. Ano? Actually, you can easily derive this kung given to. A is equals to 4R square root of 3. Kasi, di ba, yung APF, dalawa lang naman yung dalawa lang yung atom. Tapos multiply mo lang yung 4 thirds pi r cube. Tapos ito, yung formula natin kanina, ito 4r square root of 3 divided by square root of 3. I-cube lang natin yan, no? So cube nyo lang to. So magka-cancel ito, and then you can use your calculator to calculate APF. Tama ba? Lumalabas ba yung 0.68? 2 times 4 divided by 3. Mas mababa to sa FCC kasi kita nyo naman, dalawa lang siya. Ano? Times pi. Dalawa lang yung atom natin. Tapos, we have 4 cube. Tapos, divided by square root of 3. Tapos, cube nyo. Cube nyo rin, ano? Okay. Palabas nyo? 0.68. Question regarding regarding atomic packing factor of BCC. Siyempre, mas mababa to sa sa FCC. Kasi dalawa lang siya. Kanina 4. Okay, and then this is the hexagonal closed pack crystal structure, or HCP. Hexagonal closed pack. So, parang ganito yan. So, ito yun. 1, 2, 3, 4, 5, 6. Tapos yung nasa gitna, 7. So 7, tapos sa baba din 7. 1, 2, 3, 4, 5, 6. 7 din, Tapos actually, ang count lang kasi nito is lang. This is 7 plus 7, 14 plus. Sa ibang reference, 16 lamang yung number ng atoms sa sa HCP, Pero dito sa drawing parang 17. So double check na lang natin. Anyway, hindi naman talaga tayo magka-calculate ng parang relatively medyo mas complicated, Kasi hindi lang isa yung A nito eh. Marami siyang may A, may B, may C, So probably medyo challenging for an introductory MSE course na i-calculate yung atomic mass, pag given yung density ng HCP. So limited lang tayo dun sa FCC at saka dun sa BCC, Anyway, basta ito 16 atoms per unit cell. Ang example nito ay titanium at saka zinc. Kung ba ginagamit ng zinc, yung galvanized iron, So zinc yung iron yun, tapos yung pang-galvanize doon ay zinc. Of course, yung titanium, alam niyo naman yung mga bike na mamahalin para magaan, di ba? Titanium yung ginagamit. Okay, so alam niyo naman ang hexagon, when you say hexagon, it's a polygon na 6 yung sides. So 1, 2, 3, 4, 5, 6 sides, So you also need 6 molecules, tapos meron isa sa gitna. So that's why 7, 7, 14 plus yung dalawa dito, 16. Question? Okay, so dito na tayo sa density computation. Yun namang unang exercise nyo, madali lang naman yun eh. Kasi you're just being asked to calculate I think you're just asked to calculate the volume given yung radius. So basically gagamitin nyo lang yung formula na 16 times square root of 2 times the cube. So, kailangan nyo lang, syempre, kailangan memorize nyo kung ano ba yung nano. So, pag nano, 10 to the minus 9. So, Google nyo lang kung ano man yung given. So, parang sa problem, kung sa exercise nano yung given, nanometer. So, 10 to the minus 9. So, i-cube nyo lamang yung radius na yun. So, dito tayo sa density computation. Ito yung bago. Wala pa ito sa video. So pag sinasabi ko nga ang density, ang definition nito is this is equal to mass divided by volume. So when we are speaking of unit cell, tapos halimbawa given yung density nung ano, nung hindi naman tayo nakalakay. Dali lang check ko. Oh, sa loob. Meron ba? Ang dami pa. Bakit hindi automatic na pumapasok? Dali lang. Meron ba sa labas? Nasa loob naman kayo. Wala namang nasa waiting room, ano? Ano ko tinok ko na yung waiting room. Okay, nasa loob. Let's go back to our PowerPoint. Okay, so ang density ay mass over volume. So we are speaking here of the yung volume natin, gagawin natin yung volume ng cell, no? Yung volume ng cell. Okay? Ito yung volume ng cell. So ibig sabihin, itong tatlong variables na to dito, this corresponds to the mass of the cell, ano? So BC is simply the volume of the unit cell. So halimbawa, ang BC natin, bawa FCC siya. So ang BC FCC ay 16 times square root of 2 times R cubed. No, ganyan lamang yung BCFCC. Tapos iba rin yung value niya pag volume ng BCC. So pag BCC naman, hindi ko memorize, 4R, parang 4R square root of square root of 3. Tama pala. Should have trusted my square root of 3. 4R square root of 3. Tapos syempre i-cube nito. Yun yung BCC, Yun yung BC, volume of the unit cell. So magkaiba sila, Ito itong BC na to. Yun yung volume sa ilalim. Tapos ito, yung N is the number of atoms associated with each cell. So ito, halimbawa, N ng FCC, this is 4. This nasabi ko sa inyo kanina, Yung N ng BCC, this is 2. Dalawang atoms lang. Yung FCC, 4. Okay? So, number of atoms yan per unit cell. Tapos yung A is the atomic weight. Usually, ito yung tinatanong sa problem, kung ano yung atomic weight. Usually, given yung density, tapos, yung iba naman kasi dito, kaya nyo namang i-calculate, Tapos, hinahanap lamang itong A. A is the atomic weight or the molar mass, So parang imagine niyo pag you have 4 atoms tapos multiply niyo ng atomic weight. That's the mass. That's the mass of the unit cell, Tapos kasi usually ang gusto nating output ay grams per mole. Molar mass yung gusto natin. So para maging molar mass, dinidivide natin ng N sub A. Yung N sub A is the number of atoms associated. N sub A is the Avogadro's number. So, ang dimensional analysis dito, yung N, di ba, number of atoms. Atoms yung unit niya. Tapos yung A, atomic weight. So, ang atomic weight, we wanted this to be, halimbawa, grams per mole. Parang molar mass, Tapos itong N sub A, ang unit ng Avogadro's number is atoms per mole. So, ang mangyayari ito, magka-cancel out yung atoms. Tapos, meron kang mole doon, meron kang mole dito. So, yun, magka-cancel out din yung mole. Magka-cancel out din yung mole. So, grams na lang yung matitira. So, kung ano yung unit ng BC, usually, we can make that the BC, ang unit ng BC ay, halimbawa, in cubic centimeter. So, ang density niya is in grams per cubic centimeter. Nasundan? Nasundan yung yung dimensional analysis nitong formula na to. So, as you can see, another thing, as you can see, itong tatlong variables na to, itong n, a divided by n sub a, number of atoms times atomic weight or molar mass divided by Avogadro's number will give you grams. No, kasi kita nyo nag-cancel lahat. Grams na lang yung matitira. This will give you the mass. Itong tatlong variables na to. Yung mass dun sa ano, density is equals to mass divided by the volume of the unit cell. This will give you the mass. Itong tatlong terms na to. Ano? Any question before we proceed to the problem? Yan, basically formula lang naman. Ano? Dali lang yun. Supposed to be 16. Ay, ko lang. Ano? So, number of atoms per unit cell. Pag FCC 4, pag BCC 2, pag HCP 16. Okay, so let's try to solve this problem. This is problem 3.3. Theoretical density computation for copper. Copper has an atomic radius of 0.128 nanometer. An FCC crystal structure, so FCC siya, ng copper. And an atomic weight of 63.5 grams per mole. Compute its theoretical density and compare the answer with the measured density. Ano? So, gamitin lang natin yung formula. N, this is the number of atoms, no? 4. Tapos ACU, this is the molar mass, so 63.5 grams per mole. Ayun, given naman doon, ano? You can use the ano, the periodic table, ano, to find the molar mass of copper. Pero actually given naman din 63.5, ano? Tapos, FCC siya, ang formula ng FCC ay 16 R cubed times square root of 2. Yung volume ng FCC, ano? So, ito yung formula niya. BC. So, substitute nyo lang dito sa R, yung given na radius. Ang given na radius ay 0.128 nanometer. So, ito yon. No, nanometer is 10 to the minus 10. And 9, 10 to the minus 9 meters. Kaya lang, this is centimeter. So 10 to the minus, ginawa niya palang 1.28, kaya naging 10 to the minus 8. Pero kung halimbawa, 0.128, kung 0.128 na ginamit niya dyan, dapat ano yan, negative 9, tapos minus 2. So negative 7 yan kung 0.128. Ano? Nagiging minus 7. Anyway, basta nano is negative 9. Na ano niyo ba to? Na-imagine niyo yung ginawa niya dito kung paano niya kinonvert sa centimeter, yung nanometer. And then kinube niya. Okay? So this is the volume per unit cell. Tapos dinivide niya ng n sub a. This is your Avogadro's number, ano, 6.022 times 10 to the 23 atoms per mole. So pag nag-dimensional analysis kayo, magka-cancel out yung atoms. 'Di ba? Tapos magka-cancel out din yung mole. So as you can see, yung tatlong variables, yung NA at saka N sub A, this corresponds to the mass, yung grams ang matitira. No, tapos ito naman yung volume niya per unit cell. This corresponds to the cubic centimeter. So ang lalabas na unit natin ay grams per cubic centimeter. So medyo challenging yung pindutin sa calculator. So try nyo para maging familiar kayo. So sa taas 4 times 63.5. Yung sa baba we have 16 times square root of 2. Magpo-forward kayo ng isa bago nyo pindutin yung 1.28 times 10 to the minus 8. Tapos siguro gumamit kayo ng parenthesis para siguradong makukube nyo yung buong item. Ano? Gumamit kayo ng parenthesis. Tapos cube nyo. Okay? Tapos times 6.022 exponent. Forward nyo pala. Forward nyo para bumaba siya. Ano? Tapos times 6.022. Makikita nyo naman, no? Pag hindi kayo nag-forward, hindi siya bababa sa power. Exponent 23. Okay? Napalabas nyo yung 8.89 na density. Sa calculator, napalabas nyo. Yung messages, the questions. Very good, Aaron. Okay. Kumusta, Jamila? Palabas mo, 8.89. Calculator. Walang problema. Challenging yung pindutin sa calculator. You need to use the left arrow para mag-left siya. Tsaka parenthesis. Ano? Use the parenthesis para makita nyo. Lumabas yung sagot. Tama ba? 8.89. Jamila? Hindi ba? Palabas niyo ba? Jasper, lumabas ba sa calculator mo? May hawak ka bang calculator? Hawak kayong calculator. Once a week lang naman tayo. Okay, very good, Jasper. Si Jasper din pala naka-offer. Very good, June, Patrick. Okay. So, what I want you to do is I will ask you to answer this exercise. So, quiz contest kami kahapon. Ito yung tanong. Chemical Engineering Quiz Contest, National Chemical Engineering Quiz Contest. So, ito yung tanong. Question number 8 for 60 seconds, 10 points. A pure metallic solid has an atomic radius of 1.3 angstrom. You're familiar with the unit of angstrom? So pag angstrom, ilang meters yun? 10 to the negative. Pag nanometer, 10 to the negative 9. Pag angstrom, then how many meters? 10 to the negative. Anyone? Sinong Google nyo lang. Yup, 10 to the negative 10. No, 10 to the negative 10 ng angstrom. Kaya lang, syempre, mas maganda kasi kita nyo yung unit ng density niya, grams per cubic centimeter. So, i-convert nyo yung angstrom sa centimeter. So, pag centimeter yan, di ba 10 to the negative 10, mas maliit yung centimeter. So, magpa-plus 2 kayo. So, pag centimeter, 10 to the negative 8 centimeter lang yun. So, 1.3 times 10 to the negative 8 centimeter. Okay? FCC din siya. Pag FCC, ilang atoms meron sa isang unit cell? So, can you solve this? Calculate molar mass. So, basically, you need to find A. Express the final answer in 2 decimal places. Kaya? So, paki-screenshot. Bubuksan ko lang yung Do you have any question? Yep, 4 for FCC. Very good. Okay. Calculate nyo. Dapat 60 seconds lang. 1 minute. Paki-screenshot. I-close ko sandali ha. Kasi hindi ko ma-access yun. Para mabuksan pa yung sa BBL para makapag-input kayo ng sagot. So, yan. Pag may sagot na kayo, pasok nyo lang sa BBL. Tapos, check ako ng attendance for a while. Meron na naman kayo screenshot nito. Tsaka nasa BBL din siya. Check lang ako ng attendance number. When I call your name, paki use your mic Say present. So Israel Jacob Alano.
Present po, sir.
Okay. Daniel Luis Almasan. Mr. Almasan. Daniel Gian Alvarez. Sin Carlo Aquino. Sian Carlo Aquino. Every Monday may Zoom tayo ha. Attend kayo. Adrian Hart Aranilla.
Present po, sir.
Allen Miles Ardona. Allen. McLean Asanya. Meron ba McLean?
Present. Present po, sir.
Mark Emmanuel Bautista. Mr. Bautista. Marnelli Harniser. Luigi Castillo. Alphonse Corpus. Aaron Dave Cuenca. Sir Cuenca.
Present po.
Okay. Jamil R. Gray de Chavez.
Present po.
Kurt Jacob De Leon.
Present po, sir.
Jasper De Los Reyes. Muriel Angela Isguera. Edelnil Ferrer. Nielsin Flores. Shanley Formilosa. Chriselle Ann Proelda. Emmanuel Chris Ganatuin.
Present po, sir.
MC Gis Gonzaga. JYZ.
Present po, sir.
Celisa Joyce Hilutin.
Present po.
Emmy Iwata. Si Emmy. Emmy. Francis Ayan Lapitan. Genesis Francis Leocadio.
Present po, sir.
John Patrick Ligit.
Present po.
Jamela Rain Lim. Juncel Loyola. Juncel. Mark Dwayne Loyola.
Present po.
Jessica Daniel Luwalhati. Jessica. Sanya Andre Mabilangan. Sania. Mas Mabilangan, wala. Evelyn Manriquez. Kenji Marapok. Kyla Marie Mustizo. Trixie Joan Ondibilla. Aljay Pangilinan. Dan Microra. Dan Mikora. Dan Mikora. Okay, yung pangalan. Margaret San Gabriel. Ryra San Jose.
Present po, sir.
John Paul Tingal.
Present po.
Daryl Tintero. Daryl. Lalaine Tumlos.
Present po.
Alnir Chris Wayong. Francis Jerome Sagire. Okay. Yan ang nakasolve. 6:30. Meron na ba nakasolve? Ang tama? Ito nga. Ay, wala pa. Basically, gamitin niyo lang yung formula. FCC lang naman yun. So 60 times the square root of 2. Ano? Times R cubed. So 1.30 angstrom. I told you, it's 1.30 times 10 to the minus 8 centimeter. So, cube nyo lang yun. Okay lang. The density is 9.27. Ang FCC, apat na atoms. A lang yung hinahanap. A. Just be careful with the calculator. Yun lang yan. Yun lang talaga yan. You should know how to use your calculator. I'm going to increase the number of attempts para mag-attempt kayo. 3 attempts, tapos last attempt with the grade. Last attempt with the grade. Para mag-attempt kayo. Okay, para hindi kayo mahiyang mag-attempt. Kayo mag-alangan. Every Monday, magsusum tayo. Kapag naalala ko, i-announce ko na lang para mas madahan siguro umattend. 46 kayo, 20 lang tayo dito. Attend kayo once a week lang naman. Siyempre, pag molar mass yung hinahanap na sagot, should be whole number. Ano? I mean, it should be greater than 1. Parang gano'n. Ano? Pag nakukuha nyo times 10 to the negative something, mali yan. Nakakuha na? Yun, meron na. Ay, sabit. Sige, try ulit, Aaron. Konti na lang. Ito bang ginamit ko ng Molar mass? Ito bang ginamit ko ng Avogadros? Yung the Avogadros can be 6.02 or 6.022 ano times 10 to the 23. Parang 6.022 yung ginamit ko. Konting-konti lang yung mali mo. Ano? Ata dagdagan ko yung NA tapos BCC times BC use parentheses ano for 1.3 times 10 to the minus 8 before you i-cube. Mag-forward kayo. So this is the BC tapos 6.022 explaining 23 and BCC. Oo, tama si Aaron pag 6.022. Actually, okay na Aaron ko. Correct. Kaya ano ko na. Edit ko na lang. Update. Yun, okay na. Okay na yan, Aaron. Very good. 6.0 to kasi ata yung nagamit ko kanina. Oo nga, 6.0 to yung ginamit ko. Tapos pag 6.022. Anyway. Anybody else? Very good, Mr. Aaron Dave Cuenca. Very good, Jamila. Si Jamila. Got the same answer. Very good. Very good, Raira. Si Raira. Ganun din. Ano? You also attach the solution, ha? Please attach your solution. Solution ba kayo? Ba't may solution, ha? Very good. Okay. Ano to, Daniel? May mali ka dyan. Check mo yung mga values mo. O kaya yung pindot mo sa calculator. Gumagamit ka ba ng parenthesis para i-cube yung 1.3 times 10 to the minus 8? Usually yun yung mga mali dyan. Oo, hindi pa naman ngayon yung deadline. Later pa naman yun, or tomorrow pa naman ata yung deadline. Walang problema. Okay, so in the meantime, tama yun. Tama yun, Patrick. Angstrom, that's a unit of length. Angstrom is 1 angstrom is equivalent to 1 times 10 to the negative 10 meters. Or 1 times 10 to the negative 8 centimeter. Eman. Okay? Yep, that's correct. Try nyo. Yung best attempt nyo naman yung magiging score. So, attempt lang kayo. 3 ng attempt yan. Majority ba? Meron na. 20 lang kasi kayo eh. Saan? So, 6 na. No? 6 na yung mag-attempt. Okay, so very good Aaron, Dave Cuenca. Kamali Emmanuel. Ang laki naman yan. Double check mo, baka may mali lang yung pagkapindot mo sa calculator. Very good, June Patrick Ligit. Very good, Jamila Lim. So, yun na yung nakatama. Very good, Raira, 4. Very good, Lalaine, 5. Yung iba, 19 kayo eh. Siyempre, Daniel, diretso mo sa yung answer mo. Diretso mo sa BBL. Para makita mo kung tama o mali. Mag-attempt ka na lang. Sino ba yon? Mr. Ligit, mag-attempt ka na lang ulit. Ano mo na naman yung sagot? Yung man magbabago. Tapos i-attach mo na lang dun yung solution. May tanong pa kayo regarding the problem? Nag-stop ito. Okay, very good, Mr. Mark Dwayne Loyola. Recorded naman. Record ko naman. I will upload it later. Chris Hell. So, kung ano natin? Gumawa siya ng rice at saka kimchi. So that's it for today. 6:49. So I'm going to post some more lecture videos later para sa Wednesday, para sa Friday, and then we'll meet again on Monday, ha? Pag nakalimutan kong i-announce na magsusum tayo sa Monday, alam niyo na yon, basta may zoom tayo sa Monday. Okay? Do you have any other concerns? Kung wala na muna, kung wala, bye-bye. Concern passing. So, see you on Monday. Tapos, paki-monitor na lang ang BBL. So, expect na merong lecture video sa Wednesday, tsaka para sa Friday. No? Bye-bye.
Thank you po, sir.
Welcome.
Thank you, sir.
Okay.
Thank you po, sir.
Thank you, sir.